Hi, I'm Ashraf. Today we'll dive into an exciting topic, quantum computers and Turing machines. We're going to look at how computers think, how they solve problems, and what quantum computers might be able to do in the future. Let's start with something that we know. What does a regular computer do that we have in the house? Like, right, it processes information, gives us answers. Today, we are going to look at two ways of thinking about that process. One with Turing machines, another with quantum computers. Introduction to Turing machines. A man named Alan Turing came up with this idea in 1930s. Imagine a machine that can solve any problem by following simple steps, like following a recipe. This is what Turing machine does. It's a model of how computers think step by step to solve a problem. Components of a Turing machine. Now, a Turing machine has three main parts. First part is an infinitely long tape. Think of it as a huge piece of paper where you can write anything, numbers, letters, symbols. The second part is the reading write head. This this head moves along the tape, reading and changing the symbols. It's a bit like a scanner that can also print. Finally, there's a set of rules that tell the machine what to do next. With these three simple parts, Turing machine can solve problems step by step. It might seem basic, but this is a powerful concept that can do amazing things. Why Turing machine matters? So, why are Turing machines important? They help us understand the limit of what our regular computers can solve. Some problems are easy for our computers to solve, but the other are so complicated they take forever to solve. Turing machines shows how like which problems can be solved with computers and which ones cannot be. Basics of quantum computing. Now let's step into something little different. Quantum computing. Quantum computing does not use regular bits like zeros and ones, which are okay. That's zeros and ones. Instead, it uses something called qubits, which work in a strange way. They follow rules of quantum mechanics. Uh, those are the same rules that explain how tiny particles like electrons behave. And these rules let them do things that regular bits cannot. Qubits and superposition. One amazing thing about these qubits, which differs from the normal bits, is called superposition. Normally, a bit is either a zero or a one, but like flipping a coin, that during in the flip, it can be either heads or tails. The qubit can exist in both zeros and ones or both at the same time. Okay. This ability to be in multiple states at once lets the quantum computers consider many possibilities all at the same time. This is what makes them so powerful for certain kinds of problems, like the probability, finding more of the nature and predicting the nature, such things. Entanglement in quantum computing. Another interesting thing in quantum computing is entanglement. When two qubits become entangled, they are connected in a way that means changing one qubit will instantly change the other, even if they are far apart. It's like two best friends who can feel each other's emotions when they are not even together. Entanglement helps quantum computers process information much faster because they can work on different parts of a problem at the same time. Quantum gates and quantum circuits. Now, how do quantum computers actually use these qubit things to use? They use quantum gates. A gate is like a switch that changes the state of the qubit. When we connect these gates, we make what we call a quantum circuit. Just like a regular computers use circuits to process the information, quantum computers uses quantum circuits. Okay, but the quantum circuits can do far more complex things because of superposition and entanglement. Quantum algorithms. Quantum algorithms are special instructions that take advantage of these quantum properties. For example, Shor's algorithm can break really large numbers, which is important for encryption. Another algorithm is called Grover's, can search through data quickly. Imagine trying to find one book in a huge library. It would take forever to find that book, right? But the quantum computers can like do it in an instant. Comparison of classical and quantum computing. In a regular computer, we process bits at a time, one at a time, step by step, following a specific order that is designed by the computer. But in a quantum computer, because of the superposition thing that we learned, it's like doing many steps at once at the same time. It is as if you're solving a puzzle, but you can try multiple solutions at once instead of trying one by one or fitting the piece together one by one. Okay, so this makes quantum computers much faster to do certain tasks. But classical computers are still way better for our regular use cases like browsing the internet or doing our just homework. Okay. Quantum Turing machines. A quantum Turing machine is like a regular Turing machine, but uses a qubit instead of bits. This helps us apply Turing ideas to quantum computing. So, a quantum Turing machine is a way of imagining how the quantum computers might solve problems using the same setup as a Turing machine with qubits. Like how we designed a Turing machine for the regular computers that we use today. We are gonna like we will be the quantum Turing machines is for the quantum computers. Importance of quantum Turing machines. Why do quantum Turing machines matter? They give scientists a model to explore quantum computing in a structured way. You can just jot down the Turing machine in your notebook and see what will be the outcome. So that's a plus of quantum Turing machine. It's like having a blueprint that helps us to see what quantum computers might do, like how they're processing in the uh, all those quantum computers are processing. Helps us both understand possibilities and limits of these new kind of computing, which is so new. Real world application of quantum computing. Quantum computing isn't just a cool idea. It could change how we do things in the real world. For example, it could make it easier to design new medicines by simulating molecules much faster and doing much more tests at the same time. It could also improve artificial intelligence, making it quicker for machines to learn more data set and occupy and learn many data sets at the same time, not just for step by step like regular machine, but just also gathering all the data at the same time. And in cybersecurity, quantum computing could both break and strengthen encryption codes, which which could be a big deal for online security. And in the financial modeling, you can also predict the stock markets, and quantum computers is used for prediction, right? So you can use that too. Okay. I mean, if the quantum computers are so advanced, what is the challenges that we face by using these quantum computers? And what is the future of these quantum computers that we are going to use? How are those quantum computers going to evolve? How are we going to use in the daily life? Like how is it going to be any of use these new machines? Let's get into it. Even though quantum computing is powerful, it is also very challenging. Keeping qubits stable is hard. They are very sensitive and they can easily lose their state. There's also a problem of errors. Since quantum computers aren't as stable as the regular ones yet, as of now, but scientists are working on solutions and future looks promising for making a quantum computers more practical that can be used in our daily life. To sum it up, Turing machines helps us understand the basic of computation, while quantum computing opens up new possibilities. Quantum Turing machines combine these ideas, giving us a tool to imagine what the future of computing could look like. Thanks for joining me in this journey in the world of computing. Thanks.